Hello everyone, good evening. How everyone is? Kindly comment everyone. So I hope everyone is doing great, and in this video series we are going to start hydrology. So tell in the comment box how you all are. Good evening everyone, good evening, and from today we are going to start engineering hydrology. I will try to cover each and every chapter, each and every topic in detail so that nothing is left out and all the questions which will be asked in your competitive exams can be easily solved by you all. I will I will ensure that it is happening. Okay, so tell me first that I am fully audible and visible to you all. Kindly comment everyone and share it with your friends. Then we will start our lecture. Okay, today we'll start with the very first chapter of engineering hydrology, and we will in sequence we'll go on further and discuss all the other chapters. Firstly, we'll have a look on all the entire syllabus of gate and ESE. Okay, first we'll discuss the syllabus, and then we'll discuss about the chapter and what is the sequence, and then we'll start with the introduction of hydrology. Okay, so okay, you are in 8th semester, great. I am fully audible and visible. Good evening Sharif, good evening Raj, good evening Sushil, Adil, good evening everyone. Okay, so you are in 8th semester. Everyone else also can tell me like in which semester they are. Yes, definitely you will get it in the app section, no issues. Okay, obviously that is the culture of PW, so obviously you will get the DPPs and everything in your app itself. Okay, so let's start with it. So today basically you need to understand, in this class we will try to cover the basic global water balance. Okay, like how water is distributed on this entire planet Earth. We'll try to discuss it in the very first point. Then we'll discuss what water cycle is, what are the various phases of water cycle. We'll discuss that. Okay, after that we'll go on to water budget equation. But these are today's topic. But before starting our very first chapter, first let us discuss the entire syllabus. Okay, like what is the syllabus for gate examination when it comes to your engineering hydrology. So we have to discuss the syllabus first, then we will discuss the syllabus of engineering services. So if we talk of syllabus, okay, if we talk of syllabus, before coming to the syllabus, let me tell you the important chapters or how we will proceed with the chapters in sequence. We will discuss first that thing. Okay, so firstly we'll have a look on that, and after that we will after that we'll have a look on the syllabus. Okay, so one comment is there. Okay, thank you dear, thank you. Okay, what's the difference between paid? See, in paid batches, many more offerings are there. Okay, in paid batches, you have DPP, you have DPP solutions, video solutions are there. You have weekly test, you have solution to weekly test also. Okay, so many extra features are there. You can ask your doubts also, but in this, only the content is there. Okay, so this is the basic difference. Okay, now let me tell you in what sequence we are going to cover the topics. Okay, so the very first uh, chapter which we have to discuss is your introduction to hydrology. Okay, the very first one, the very first one. Okay, the very first one will be your introduction to hydrology. Okay, so sir, what we are going to discuss in this chapter? So in this chapter we are going to discuss all the basic things. Okay, like why we are studying hydrology. Okay, there are various aspects. Okay, we have engineering aspect. Okay, we have social aspects, we have different aspects. So basically we'll discuss engineering aspects, and I will tell you like why we are studying hydrology in the very first chapter. Okay, then we'll discuss some basic terms like what is catchment area, what is watershed, what is basin. Okay, all are one the same. Then what is catchment leakage. Okay, we'll have a deep discussion on the important terms which will be dealt further in your engineering hydrology. And after that we'll go on to water cycle, like what is your hydrological cycle and what are the various phases. Then we'll discuss the water weight equation, the very famous one. Okay, and most important for gate examination. So in this chapter we are going to discuss the very basic aspects. Okay, the basic terminology, the basic aspects we are going to cover in this introduction to hydrology. I will make sure that you develop a keen interest in this subject. Okay, I will make sure that you are thorough with each and every single concept, so that you are you are developing an interest in it. Okay, so I will make sure that interest is developed in this subject. I will make sure that uh, the examples which I am citing are so realistic. Okay, and I will give you the data of each and every department in such a way that it will be very very interesting for you all to learn. Okay, so I hope you will enjoy it. Okay, so the very first one will be your introduction to hydrology. This is the first chapter which we are going to discuss. After this, After we'll understand all the basic aspects of your engineering hydrology. After this we'll go to your precipitation chapter. Okay, after this we'll move on to the precipitation. Okay, after this we'll move on to your precipitation. Okay, I will write this later. I will write this later when I will uh, make sure that you are able to understand the water cycle. Okay, after water cycle I will come here. Now let me have a quick uh, okay, what I was saying. Yes, let's have a quick look on the syllabus first. So the very first we have to see hydrological cycle, same things I will write here. Then we have precipitation, then we have evaporation, evapotranspiration, watershed. Okay, watershed is nothing but your catchment area only. Then we have infiltration, then unit hydrographs is very important from your gate point of view. Then we have hydrograph analysis. What is hydrograph? How, why we study it? Okay, so we'll discuss that hydrograph analysis. Then what is flood? How we estimated? What is routing? What is reservoir capacity? Okay, why we need to determine the reservoir capacity, that we'll discuss. Channel routing, all these things we have to discuss. And at last we have groundwater hydrology. And similar to this we have the syllabus of engineering services also, more or less it is one and the same. Okay, so let's start. Okay, first let's start and then I will cover the then I will write all the chapter names. Okay, but let me give you some basic idea behind your hydrology. After that I will give you the entire sequence so that everything is fully clear to you all. Okay. Okay, so yes, it will be sufficient for ESEN each and every civil engineering exam. Okay, no issues in that. Be it any civil engineering exam, be it your GATE, be it your engineering services, be it state AE. Okay, be it any exam, all the exams will be thoroughly covered. Okay, and this batch has been launched in English so that all the South Indian students and all those who are only comfortable in English, okay, they are able to learn from this lectures. Okay, I will make sure that nothing is left and all the questions of your examinations, be it any civil engineering competitive exam, are solved by you all. Okay, so simply what you have to do, you have to simply make notes. Okay, all the notes will be given to you after the end of each and every lecture. Okay, all the notes which I am writing, all these things which are typed here and the things which I will write here with annotations, all the things will be given to you in the PW app itself. Okay, so all the notes will be given to you at the first hand. Secondly, you have to solve DPPs, you have to solve previous year questions from your side. Okay, and keep revising all the content and nothing will be left and all the questions will be easily solved after that. Okay, so I hope this thing is very clear to you and obviously this will be sufficient for ESE. Who has asked this? Okay, Ankita has asked this. Okay, it will be thoroughly covered. Okay, so now first thing, like what is hydrology? What is hydrology, sir? Hydrology simply means the science of water. See, hydro means what? You all know what is the meaning of hydro. Hydro means water. Hydro means water. Logy means study. So, study of water. Okay, sir, we have understood hydrology means study of water. Now, sir, why we are interested in this study? Okay, the most important thing, why we are interested in this study. See, you all know water is a very important resource. You know what resource is? Resource means something which can be used. Some, like, see, this is a pen with the help of which I am writing on this smart board. Okay, so this pen is a resource. My mobile phone is a resource because I am using it. So whatever thing we are using which is helpful to us is a resource for us. Okay, yes or no? So water is one of the most important resources for you human beings. Why? Because we have so many needs which are being sufficed with the help of water, such as drinking. Such as drinking, we need water for drinking. Okay, the utmost priority. Then we have to grow crops with it. Okay, we are doing irrigation with it. Okay, what else? It is being utilized in your power sectors. Okay, to in order to produce electricity, water is required. Yes or no? Do you know this? Okay, so water is a very, very important resource. Now you need to understand that water is not unlimited. Okay, most of the people think that water is unlimited, but you should understand that the pure water or the water which we can utilize is limited in quantity. It is in rare quantity, so we have to manage it. We have to manage it, otherwise because of you can say mismanagement, some population will suffer drastically. Okay, so we have to manage it, and if we want to manage it, okay, so where that water is existing, okay, how it is distributed on our planet earth, that we need to understand. How we can extract it, that we need to understand. We have to have the idea of precipitation, we have to have the idea of your groundwater. How much is the volume of water which is present in ground? Okay, so what is the volume of water in different phases? How your water is distributed on this planet earth, that we have to understand so that we are able to manage it properly. Okay, I hope this is clear to you. That's why we are interested in this subject. This subject is basically our water resource. Okay, water resource management. Okay, in entire India, you all know many states are there. Yes or no? In entire India, we have different states, and each state is managing their own water. Okay, in each state there is a department known as water resource department. The basic function or the basic work of this department is to manage the entire water. Okay, let us take an example. Let us say we are talking of Maharashtra. Maharashtra is one of the states which have uh, water. Okay, every state has water resources. Like some states have abundance groundwater supply, some states have rich rainfall. Okay, some states you must be seeing that rivers are there. Okay, like in UP, like in Uttar Pradesh, you have great rivers. Okay, in Uttar Pradesh you must be seeing that major 8 river basins are there. So in some states rivers are there, in some states groundwater is there, in some states rainfall is in good you can say uh, in sufficient amount. Okay, so in every state water is coming. Okay, in every state water is coming. Like ultimately what is the main thing? Ultimately whatever water is available there yearly, on yearly basis, you have to have a budget of that. You have to have an idea of entire volume of water. Okay, like how it is distributed, how we'll manage it. Okay, where we can store it. We will build dams. Okay, so that water is tapped and water is stored there. Okay, so we have different lakes so that water can be stored. So entire state, each and every state on their it is the responsibility of water resource department to manage that water and to cater the demand of the entire population. Okay, each and every state is doing that, and if water is in less quantity, they have to borrow it. Okay, they have to borrow it or bring it from somewhere or the other. Okay, so this is the ultimate thing. But you all know that population is growing on continuously, and because of this growing population, there is a huge, you can say, pressure. There is a huge pressure on this water resource department because they have to fulfill the requirement. Yes or no? So now come the engineers. Okay, now comes the engineers whose responsibility is to manage this water, to increase the efficiency of each and every to increase the efficiency of each and every system in such a way so that water is not wasted. If this water will not be wasted, it will be utilized properly. Yes or no? So this is the ultimate aim. Yes or no? Yes, it will be sufficient for SE mains also. Okay. Okay, so this is clear. So now, what is hydrology? So hydrology is basically what? It deals with the occurrence, circulation and distribution of water. What does it mean? Where this water is occurring, how this water is circulating in this, on this planet earth. Okay, how it is moving, we need to understand that. Okay, so that we can tap it properly and cater our population. How it is distributed, what is the meaning of how it is distributed? It simply means like how much volume water is present in rivers, how much volume water is present in oceans, how much volume water is present in your groundwater, like that. Okay, I will tell you that, no need to worry. And how much water is present in our earth's atmosphere. Some of the water is also present in human bodies. You all know that we are 8 billion in number. Okay, on this entire planet 8 billion people are living, and in each and every human body, you know that 70% is water. Everyone knows this. Okay, so some of the water of this planet earth is also stored in human bodies. Yes or no? So how and where this water is occurring, how it is circulating, how it is distributed on this planet earth, we need to understand that. Because if we will not understand that, how we'll manage it? Firstly we need to have a idea of the entire water. Okay, I will tell you how your global water is distributed just in the next slide. Okay, now in general sense we can say that we are more interested in estimating the water resources. Sir, we are interested in the estimation of water resources. Sir, why is there is a need of estimating the water resources? Can you tell that? See, you need to understand, if you are not able to estimate the water resources, how much is the quantity of water present on this planet earth, then how will you cater a population? Let us say you are living in a city A, and in that we have a population, let us say, of 10,000, and each and every person is consuming 100 liter of water daily. So what is the total amount of water that we need to supply to the city, that you can calculate? Yes or no, based on the population of that city? Yes or no? Can you tell me? Can you tell me in the comment box? So firstly we have to have an idea of what is the amount of water that is available in that city, in that state, or be it any area. Yes or no? So firstly we have to estimate water resources. Okay, firstly we have to have an idea of how much quantity of water we have in each and every city, in each and every state. And basically today I will talk about entire India, how much water is present in entire India that we can use. I will tell you the exact um, you can say exact volume of water that India is receiving every year and how much water is being wasted. Okay, so I will give you the exact idea about it. No need to worry. In the just next slide, I will tell you the entire data. So basically, you need to understand that in general sense, engineering hydrology is dealing with the estimation of water resource. We have to exactly evaluate or calculate or estimate how much is the total quantity of water that we are available with. Okay, and then we'll distribute it. After that, we have to understand the processes. Okay, all the processes such as precipitation, runoff, okay, evaporation, transpiration. See, these processes all are interlinked with one another, so we need to understand all these processes and their interaction. Okay, this will also help us in managing the water. And at last we have two problems. What are those two problems? See, sometimes you have water in very, you can say, less quantity. Sometimes water gets water becomes deficit, or you can say there is crisis of water. In that condition is known as drought. You all know this, yes or no? Can you comment down? Everyone knows drought, yes or no? Good evening, dear. So I hope you all know what drought is. Drought is a condition in which there is shortage of water, there is crisis of water, yes or no? There is shortage of you can say drinking water, all the water level goes down, and you can say soil moisture is not in such a quantity, is not in such sufficient quantity that your crops can grow, yes or no? So that is a condition of drought. So drought simply means deficiency of water, yes or no? Yes sir, you all know deficiency of water. And the just opposite condition of this is your deficiency of water, and just opposite condition is your flood. Okay, now what is flood? Flood means excess of water. When you have continuous rainfall, okay, when you have continuous rainfall, or you can say rainfall intensity is very very high in certain area, and rainfall is happening for a very very prolonged time, then you will say that floods are occurring. Flood simply means what? When uh, whatever you have whatever boundary or whatever banks of your river we have that are being overtopped. Okay, so if that overtopping of water is happening, then that is nothing but your flood only. So flood means, flood simply means excess of water. So we have two extreme conditions. Sometimes deficiency is there, acute deficiency, and sometimes we have excess of water. Okay, so both the conditions are there. You need to understand, as an engineer, it is our responsibility to manage these excess conditions. Okay, to manage these acute conditions. Sometimes we have less water, so what is the solution to that? That we have to develop. Okay, now when we have excess of flood, when flood water is very very you can say is destructing the area. Okay, it is uh, destroying all the flood plains. Okay, and it is affecting many villages. Then what we have to do? How flood fighting work is done? So that is the work of an engineer. Okay, that is the work of an engineer. Okay, let me give you a quick example. Okay, just a basic example with the help of which you will have the idea how to tackle these problems. Okay, how to tackle these problems. Understand, let us say see, drought basically means drought will happen when you have less rainfall in some country. Okay, imagine in India, in this very year, rainfall is not happening. Okay, rainfall, or you can say rainfall is happening but in very less quantity. Then obviously water shortage will be there, yes or no? Because all the water which comes in India is mainly because of precipitation. Do you know this or not? Kindly comment in the comment box. If I'm asking let me ask one question, one very beautiful question. Can you tell me all the water which you are seeing on this Indian subcontinent is coming from which source? Can you tell me? All the water, be it your rivers, be it your lakes, be it your groundwater, any sort of water which you are seeing on this Indian subcontinent is coming from which source? Can you comment down? Comment everyone. Is coming from which source? Can you tell me? Comment everyone. Thank you, dear. Yes, only one source is there, that is nothing but your precipitation. Yes, absolutely correct. All the water which you are seeing here is only because of precipitation. Okay, can you tell me how much water India receives, how much water India receives, total, what is the volume of water which India is receiving in form of precipitation? Can you tell me? Can you tell me how much is the total volume of water which India is receiving in the form of precipitation? Let me tell you. Let me tell you. It is very simple. Approximately 4,000 BCM. Okay, approximately 4,000 BCM of water is the amount of water which is received by Indian subcontinent every year. Okay, and this is the total quantity of water which is available in this India. Okay, and some water gets wasted, obviously you all know, and some water we have to tap and utilize. Yes or no? Yes or no? So this is the amount of water which is being received by our Indian subcontinent. I hope you all have understood this. This is very simple concept. Now out of this total water, you need to understand, out of this total 4,000 BCM. Okay, first let me tell you what is BCM. BCM means, what is the meaning of BCM? BCM means simply, BCM is simply what? Billion cubic meter. Billion means 10 power 9. Cubic meter you all know. Okay, cubic meter you all know. Meter cube, simply 10 power 9 meter cube. Okay, meter cube is simply your unit of volume. You all know this. Set 10 power 9. 10 power 9, or you can say 100 crores. Okay, 100 crores meter cube is your 1 BCM. So this is the total amount of volume water which is being received by your Indian subcontinent every year. So this is your total rainfall in India. Okay, this is your total rainfall in India. Okay, sir, understood. Clearly understood. Now you need to understand that out of this 4,000, out of this total 4,000, only 1815, only 1850 kilometer cube. See, kilometer cube and BCM is one and the same. Also you need to understand 1 BCM is 10 power 9, and you all know, see, this 10 power 9 means 1000 meter cube. Yes or no? See, 1000 cube is 10 power 9, meter cube is meter cube, you all know this. This is 1 kilometer, this is 1 kilometer. Okay, so we can simply write kilometer cube. So 1 BCM is nothing but 1 kilometer cube. One and the same. I hope this is clear to you. Yes or no? So kindly comment everyone. Out of this 4,000 BCM or 4,000 kilometer cube, how much water is available for us? Only 1850. Rest 2150. How much water is left out now? If we'll subtract 1850 from 4,000, how much water we are left with? Only 2150 kilometer cube. Okay, so 2150 kilometer cube of water is being simply wasted out in form of evaporation. Okay, this is the water which is being evaporated nowhere. Okay, this water we are unable to tap. Okay, this water is being evaporated from your, see, more than half of the water has been wasted only in the form of evaporation. So can you tell me, will we be able to utilize this water? No, we will not be able to utilize this water, and the water which is left behind after your rainfall is how much? Can you comment? Now one question can be framed in your state examinations, like how much is the quantity of water that we can utilize? How much is the quantity of water, or tell me what is the total quantity of water which is available in Indian subcontinent in the form of water resource? Can you tell me what is the volume water? Comment everyone. One question has been asked, the total water resources in India is how much? So you will say the total water resources in India is, the total water resources in India is, comment everyone, the total, see, rainfall is 4,000, but only 1850 kilometer cube is remaining. So that is the total water resource is in your India. Okay, so the total water resources in Indian subcontinent is how much? In India is simply 1850 kilometer cube. Yes or no? You have to remember this data. This is very, very important. This is very important. Okay, so this is the amount of water which is your total water resource. See, this is the only amount of water which will be utilized everywhere. Okay, be it drinking, be it irrigation, be it power sector, be it for any recreational purpose. Okay, be it any use, only this is the amount of water which is left there. Okay. Okay, so Sushil is asking, like, is there any method to reduce evaporation quantity? Yes. See, There are different methods. We'll discuss that later when we'll discuss evaporation. But as of now, see, this is the amount of water which is remaining. Now, you have to understand out of this, out of this, approximately 1200 only, approximately 1200 can be utilized. Okay, approximately 1200 can be utilized. Approximately 1200 can be utilized, and remaining is how much? When you subtract it, it will be somewhere around 650, or you can say 700. Approximately 700 cannot be utilized. Now you will be asking, you must be wondering, sir, why this 700 water cannot be utilized? See, because of topographical constraints. Some water falls, you can say some water is going in that area where we cannot go. Okay, that places are inaccessible. Those places are so remote that human cannot reach there. Yes or no? So because of topographical constraints, or you can say because of inaccessibility, we will not be able to reach such places. Okay, so because of topographical constraints, approximately 700, see, if you will sum it up, it will be approximately 1900. Okay, so you can say because of topographical constraints, we are losing more water. Approximately 700 kilometer cube we are not able to access. We will not be able to reach there. Yes or no? Now, out of this total 4000, only 1200 we are left with. Okay, only 1200. Now, out of this 1200, you need to understand some water remains on surface and some water goes in the ground. Some water remains on the surface and some goes in the ground. Okay, sir. Now you need to understand that out of this 1200, out of this 1200, 700 kilometer cube of water remains on surface, which you see in the form of lakes, which you see in the form of rivers, oceans, seas, like that. Okay, whatever water, we cannot exactly see seas and oceans because it is falling in the Indian subcontinent. So basically we are discussing rivers and lakes. Okay, rivers, lakes, and any kind of pond, that is your surface water. And how much is remaining? 500. 500 goes inside your ground. Okay, 500 goes inside your ground, which is stored in the soil itself. So basically, if someone asks you exactly how much water we are left with, what will be your answer? Can you tell me how much water we are left with? Can you tell me the answer? Kindly comment, everyone. Sushil, I will tell you what are the exact methods so as to reduce the evaporation when we'll discuss evaporation. So I hope this entire thing is clear to you. So the total water resources is 1850, and out of this 1850 we are only left with how much? Everyone comment. See, everyone try to participate because it will help you in remembering these facts, you can say, in long term. Okay, otherwise you will forget it. Yes or no? So how much water we are left with? How much water we are able to utilize easily? Kindly comment, everyone. Everyone comment. Yes or no? So how much water we are left with? We are only left with this much water, only 1200. Okay, so now after this, if we talk of global water, see, in entire uh, if we talk of global water distribution, you need to understand, if we talk of global water distribution, so this, on this entire planet, the amount of water is how much on this entire planet, be it oceans, be it seas? Kindly comment, everyone, what is the total amount of water present on this planet earth? Sir, it is somewhere around 1400, around 1400 million kilometer cube. It's huge quantity. Okay, yes or no? Very good. Comment, everyone. How much is the total quantity of water present in this entire world? Sir, approximately 1400 million kilometer cube. Okay, it's huge quantity. It is huge quantity. You need to understand this. So uh, let me write it on the next slide. See, the total quantity of water which is present on this globe is 1386 million kilometer cube. Yes or no? Yes, sir. Understood. Out of this, you all know some part is saline. Okay, some water is saline and some water is fresh. You all know this thing. Okay, so saline water simply means the water which is rich in mineral content, the water which is having salt content in it. Okay, soluble salts, dissolved salts in it, that is your saline water. Yes or no? You all know ocean and seas water is saline, which contains huge quantity of salts in it. Approximately 97% water, approximately 96.5 exactly, or approximately we can say 97% water is your saline water. Yes or no? So if you take 97% of this, it will be approximately 1350 million kilometer cube. Yes or no? So this is your saline water. Now remaining water is your fresh water. You all know this. Remaining water is your fresh water, which is also your potable water. Potable water, which means we can utilize it easily. Okay, we can utilize it. Approximately you can say 35 million kilometer cube. That is approximately 3%. Okay, 35 million. See, you can subtract 1350 out of 1386, so it will be approximately 13.5 million kilometer cube. You can remember this figure roughly as 1400. Yes or no? Yes or no? Yes. Perfect. Sir, is there any loss in soil due to air voids? Yes, Sushil, you will understand the concept later. Don't worry. Okay, that will come later. I will make sure that everything is clear. See, you have to have patience right now because many things are not covered. But when these topics will move further, you will try to understand. You will get the entire concept. Okay, so no need to worry. So out of this fresh water, you need to understand. Out of this fresh water, some water is present in ice caps and glaciers. Okay, can you tell me how much is the percentage of water which is present in your ice caps and glaciers? Some water you all know, is present in ground itself. Okay, some water is present in ground inside the surface. Some water you all know is present on the surface. Okay, some water you all know is present on the surface, that is your surface water. Yes or no? And some water is present in other sources, such as you all know that some water is present in atmosphere, some water is present in human bodies, like that. Okay, that is fresh water only. So that is your other sources. So you need to understand. See, you will be surprised. Or you can say astonished, when you will be getting the fact that the total quantity of water which is in solid form, or you can say frozen form, is approximately 70%, or exactly 68.7%. See, most of the fresh water you can say is frozen. See, only 3% we have fresh water on this planet. The entire water which we have, out of that only 3 to 3.5% is fresh, and out of that majority portion, approximately 70% water is frozen. Sir, approximately 70% water is frozen. So can you tell me one question? I am asking you a simple question. Can you tell me what percentage of fresh water, listen the question very carefully, what percentage of fresh water, I am saying what percentage of fresh water is present in liquid form? Can you tell me? This is a question. Okay, what percentage of water, of fresh water, is present in liquid form? Can you tell me? Kindly comment everyone. Percentage of fresh water which is present in liquid form, can you tell me? Everyone kindly comment. See, this is important question. Approximately how much? Approximately 30%. Why? Because this is 70, approximately 70% is in frozen form. So the remaining will be in liquid form. Yes or no? The remaining will be in liquid form. Yes or no? Yes or no? Out of 100, if you are removing 70, 30 will be left only. Okay, so this type of question can be asked. Approximately 30%, exactly 30.1% of water is present in ground. Okay, you all know that we excavate wells. Okay, so that water which is coming from ground is your part of groundwater only, approximately 30.1. So sir, you can say that most of the water, 70% is frozen, 30% is in ground. Now remaining surface and other resources will be very very less. So in surface you have only 0.3% of water, and other sources you have only 0.9% of water. Okay, So you need to understand that most of the fresh water is frozen and the remaining water which is in liquid form is present in the ground. In surface and in other sources you have approximately 1% water. Okay, yes or no? Yes or no? Perfect. So you need to understand, and whatever water we are seeing, whatever water we are seeing in the form of lakes and rivers is your surface water only. Okay, that is your, see, you must have seen lakes, yes or no? You must have seen lakes, you must have seen wetlands, you must have seen rivers. So the quantity of water present in lakes, wetlands and rivers is not much. That is only 0.3% of your fresh water. Fresh water is also 3%, and out of that 3% you have to take only 0.3%. So the total quantity of water which is present in rivers, lakes and wetlands is very less. But still we are dependent on that. Most of the water, approximately 87% is present in lakes. Out of this surface water means the water which is present on the surface of earth, yes or no? That is in the form of lakes or wetlands. That wetlands you all know, swamp area, marshy area. Okay, you must have seen that in swampy and marshy area lotus is blooming out, so that is your swampy and marshy area. Okay, so in swamps and marshes approximately 11% water is there. 87% is lakes, 11% in wetlands, and in rivers only 2%. See, out of this fresh water not even 1% is present on surface, and out of that surface only 2% is present in rivers. That means the total water which is present in all the rivers of this planet, all the rivers of this world, is so less, only 2%. Yes or no? Can you appreciate this fact? Okay, Deepak is saying board is not clear. Okay, board is not clear, just wait a second. I think now it is clear. Deepak, now I think board is clear. Yes or no? Comment once if board is clear or not fully. I am able to see everything properly. Yes or no, Deepak? Okay, so let's proceed. So this is your entire global water distribution, and you can see that out of this fresh of the total fresh water, we have 70% in frozen form and approximately 30% in groundwater, and the remaining little surface water which we have, mostly it is in lakes. Most of the water is present in lakes itself. Yes or no? So this you need to remember. I hope this is clear to you. So the total water which is present on this planet Earth is your 1386, or you can say 1400 million kilometer cubes. And one more data that I have shared. See, this is a rare data which you will not easily find on the internet. That how much how much rainfall is received by India. It is approximately 4000 BCM or 4000 kilometer cube, and the total water resource which we are left with is only 1850, and out of that 1850 we have to utilize. Okay, see, this 700 we also can extract if we are crossing your topographical constraint, that then we can utilize that water also. Okay, so I hope this is clear to you. Now, why I have told you this thing, see, in some places when rainfall is not in proper quantity, then you will see that deficiency of water is there. So how to overcome this deficiency? We were discussing that two problems were there. First was your excess, and the second one was your deficiency. These are two extreme conditions. Okay, so how we tackle it? So in order to tackle a drought, you need to understand, if you want to tackle drought, what we have to do, we have to make dams. Okay, let us say this is a river. Let us say this river is flowing properly, and you have obstructed its flow and you have constructed a huge dam. Okay, so let us say this is your rainy season, let us say this is your monsoon season. So what will happen in monsoon season? Sir, in monsoon season this rain will be more, and most of the water you will see in your river, most of the water you will see will reach after runoff into the river, and river water will be at its highest level in the monsoon season. So what will happen, you will see that this water will get stored, okay, behind this dam, behind this barrier which you have constructed on the river valley. You will see that huge amount of water has been stored. So when excess water is there in monsoon season, in that season we will try to store that water behind huge dams, yes or no? So that when summer comes, so that when dry season will come, in that case when rainfall will not be there, then we will utilize this water only, then we will utilize this water, yes or no? Can you understand? So sir, whenever excess water is there, we will tap it, we will store it behind huge dams, or you can say in big ponds or in lakes. After your monsoon season is over, when your dry season will come, then we'll utilize this excess water which we have stored. So this is a method, or this is a strategy with the help of which we can tackle droughts. Okay, so we have to build dams across rivers. Okay, if we have to manage water, we have to uh, construct huge dams so that water can be stored. Now also when flood is there, see all the flood water, you all know, in whatever city you are living, you all know that after rainfall all the water drains into the main river of your city, yes or no? So you need to understand that whatever water after rainfall goes into the river, that will cause the river water, or you can say that will raise the level of water. When the river water will increase, flood will come. So that excess water can also be stored behind dam, yes or no? Dams are huge. When rainfall is in excess, river water will raise, and that excess flow, or that excess water can also be stored because it has a huge capacity, yes or no? Yes or no? Can you understand it? So the construction of dam on the river valley is an indication that we are able to tackle, or you can say we are able to combat both the condition. When excess water is there, we can store it. When shortage of water is there, we can utilize that water. Okay, we can utilize that water. So it is a you can say construction of dam is an optimum solution with the help of which we can cater floods also, and we can counter drought also. Okay, so this is just an example, many other techniques are also there, we'll discuss later, no need to worry about that. So in basically you need to understand why we are studying hydrology. I hope this is clear to you. I hope this is clear to you. Everyone kindly comment. Okay, try to participate in the session so that we are able to remember everything for a long time. Okay, try to participate. So now you have understood clearly why we are studying hydrology. We are studying hydrology so that we are able to cater the entire population. We are able to manage the water resources. We are firstly able to estimate water resource so that we can cater our population, and we are able to combat, we are able to tackle the extreme problems such as floods and droughts. I hope this is clear to you. Yes or no? Is it clear to you? Kindly comment everyone. Kindly comment everyone. I am able to see your comments. Is this thing clear? Yes. After this, we will try to understand. After this, we will move on to your water cycle. Okay, very beautiful thing. We will move on to water cycle, and we will try to understand what water cycle exactly is. Because without water cycle, you will not be able to understand engineering hydrology. So I hope now hydrology is clear to you. Why we are studying hydrology and what is your how your water is distributed. Okay, we have understood the distribution of water on entire planet Earth as well as in India. Okay, how much water is received by your India, that we have also understood. Okay, and this is your global water distribution. After this, we'll move on to your water cycle. Okay, after this, we'll move on to your water cycle. Okay, what is your hydrological cycle, how it is uh, driven. Okay, voice is low. I don't think so. Voice is low. Voice is quite good. Try to increase voice from your end. Okay. Now we'll start the hydrological cycle, which is your water cycle. Okay. Okay, so now what is water cycle? See, water cycle is a very basic thing. See, water cycle is nothing. See, water cycle means what? It is a cycle in which water is moving from one phase to another. Simple. It is a cycle in which water is moving from one phase to another. So we need to understand phases. We need to understand different phases. Okay. Basically, you need to understand that there are only three phases. Basically, there are only three phases. You need to understand this. Okay, it's very simple. Okay, so tell me what are those three phases. See, let us start from oceans. You all know that because of the sun, because of this, you can say source of heat energy. You all know sun is a great source of heat energy, and because of this uh, tremendous amount of heat energy, what will happen? The ocean water will evaporate. The ocean and sea water will evaporate. Yes or no? So this ocean water will evaporate and will form clouds. Okay, or and you can say this because of this evaporation, when this water vapor when this water vapor is getting saturated, it will condense to form clouds. Okay, so the very first one is your oceans. The very first thing which starts is from your oceans, and what is the phase? That is your evaporation. Okay, so from ocean evaporation starts. After this, precipitation will happen, and because of this, clouds will precipitate water, and that water will form will fell on the land masses. So sir, you are simply saying evaporation is there, then precipitation is there. Yes or no? Firstly evaporation is there, and then this entire you can say rainfall will happen on the ground, or you can say on the land masses. That is a precipitation part. After your precipitation, what will happen? All the water, you can see that some water will infiltrate, some water will be intercepted by trees or buildings. Okay, some water will be stored in the depressions. Okay, some water will, so you can say after precipitation many losses are there. After precipitation you will see many different kind of losses are there, and whatever water is left off after precipitation, whatever water is left off after all the losses have happened, runoff will happen. Okay, runoff will start. Okay, you will see that all the water will be running off and ultimately will reach into the rivers, and that river ultimately join your seas and oceans. So basically sir, you are saying it's a three-step process in which evaporation is there, precipitation is there, and after all the losses we have runoff. After all the losses we have runoff. So three things: evaporation, precipitation, and after losses we have runoff. Understood? So this is your basic water cycle. We will understand it in a great detail. Okay, we'll understand in great detail. So you need to understand this. You need to understand this thing. So let me draw it. Okay, let me draw it so that you are able to understand clearly. So if you want to understand water cycle, first let me draw the landmass. You know what landmass is? Landmass is a place which has a higher level. Okay, see, landmass is a place which has a higher level as compared to your oceans. Okay, landmass is a place which has a higher level as compared to your oceans. Yes or no? Wait a second. Let me draw the good diagram. Okay, so this is your impervious stratum. What is the meaning of impervious stratum? Which means water cannot go beyond this level. Okay, water cannot pass this level. Okay, you can say these are rock layer, or you can say this is impervious stratum or impervious layer below which water cannot go. Below which water cannot go. Understood, sir? Now this is your landmass. Okay, this is your landmass. This is your river. Let me draw a beautiful river here, and like this your landmass will go declining. Okay, so this is your landmass. On this beautiful landmass you must be having certain trees, buildings. Okay, like that you have different features on your land masses. Okay sir, so on this land mass you have beautiful trees. Let me draw the trees with the green ink. Okay, so these are some trees which you have here. Okay, so now let me draw all these water. Some water will be present in river. So this is your groundwater level. Okay, you need to understand this is your groundwater level. Okay, this is your groundwater level, and these are your oceans. This is your ocean. This is your entire groundwater. You all know that in soil we have This is your river. Okay, sir. So this is my topography in this region. Now I will draw what? See, the water cycle is being driven because of one thing, which is nothing but the sun. Okay, you all know that sun has tremendous amount of energy. Let me draw a beautiful sun here. Let me draw a beautiful sun out here. So this is sun. Okay, this is sun. Okay, sun has beautiful eyes, beautiful smile. So this is a sun. You all know this. You must have drawn it in your childhood. Okay, because of this sun, you need to understand we have huge amount of heat energy which is being received by this entire planet, and because of this you will see that water will start evaporating from oceans. Okay, this is your evaporation. Okay, let me write it uh, let me name it by number 1. Okay, what is the meaning of 1 here? 1 means evaporation. Yes or no? These are different phases of water cycle. You need to understand this. So 1 is what? Can you tell me what is the meaning of 1? Sir, 1 is simply evaporation. 1 is simply evaporation. See, I will write all the phases one by one. So 1 is what? Evaporation from oceans basically. And also you need to understand not only oceans. See, oceans has more surface area. Ocean has more water. That's why most of the water will be evaporated from oceans only. Yes or no? Less water will evaporate from rivers, less water will evaporate from lakes, but most of the water will evaporate from your oceans only. Why? Because it has more water. But 1 will indicate evaporation from oceans, rivers, okay, and soil. 1 indicates your evaporation. Let me indicate this in diagram also. So evaporation from your rivers also, that is also 1. Evaporation from soil also, because you all know that some soil soil also contains some moisture, so that is also getting evaporated. Yes or no? Yes or no? Volume is low, but I don't think so. Hello. Now now tell me if it has increased or not. Hello. Volume, I think volume is perfect. I think volume is, everyone kindly comment is my voice is fully clear and audible. Okay, so this is evaporation from your oceans. See, these are oceans. Okay, sir, understood. These are oceans. These are your rivers. These are rivers, and this is your soil mass. Okay, so from soil, rivers, oceans, wherever we are getting water, it is being evaporated in the very first step. Now, in the second step, what will happen? You all know that clouds will form. Yes or no? Clouds will form. Okay, clouds will form, and these clouds will start moving towards land masses. Okay, because of land breeze, you all know this. It will start moving towards land masses. Okay, so this is your, these are your clouds, and it will water will fall down. This is nothing but your precipitation. This is nothing but your precipitation. So what is 2? See, precipitation also happens on ocean also. Precipitation also happens on ocean also and on land masses also, but more water falls on land masses. You need to understand this. Okay, so sir, you are simply trying to say the second point is precipitation or simply rainfall. Okay, precipitation has different forms, but we are more focused on uh, rainfall only. So second is nothing but your precipitation. I hope this is clear to you. So we have evaporation, after that we have precipitation. Okay, now whatever water will reach your surface of earth, okay, some water will start infiltrating the topsoil. Some water will move inside the topsoil, and the water which will move inside the topsoil is known as infiltration. 3 is what? Infiltration. If someone asks you what is infiltration, if someone asks you what is infiltration, I will simply say infiltration is nothing but movement of water. Let me write the definition here. Okay, these are all the definitions. Infiltration is nothing but simply movement of water. It is simply movement of water from topsoil only. Movement of water from topsoil, only topsoil. Okay. Movement of water from, okay, movement of water into the topsoil. Movement of water into the topsoil of Earth's surface. Into the topsoil of Earth surface. Okay. These are different phases which I am indicating correspondingly in your diagram itself. Okay, so this is your infiltration. Okay, infiltration will be denoted by I, yes, IF. This is not IF, it will be denoted by IF. Then we have precipitation. I have told you what precipitation is. Precipitation means simply the water which is getting deposited on your earth surface. Okay, precipitation means deposition of, precipitation means what? Deposition of water on earth surface. Precipitation means what? Deposition of water on earth surface in form of basically rain, in form of rain, or sometimes you can say snow is also there, sometimes hailstorm is also there, etc. We have different forms of precipitation that we'll discuss later, but basically precipitation is what? Deposition of water on surface in the form of rain or snow, etc. What is evaporation? Sir, evaporation is simply nothing but transfer of water from liquid to gaseous phase. Transfer of water, you all know this. Evaporation means water is getting converted from liquid to gaseous state. Yes or no? So transfer of water from, transfer of water from liquid to, from liquid to gaseous state or vapor state, you can say. Okay, so these three we have discussed till now. These three we have discussed till now. I hope this is clear to you. So infiltration simply means what? Water moving inside the topsoil only. But you need to understand at the same time, if water is moving from one soil layer to another soil layer, from that another layer deep down into another layer, and ultimately joining this water table. See, I hope you understand what water table is. Okay, see, water table is nothing but this is your soil mass only, which is completely saturated with water. If your soil mass is completely saturated with water, then that formation is known as your saturated formation, which is nothing but groundwater itself. This will discuss in one chapter later. Okay, so this is your groundwater, you need to understand. Okay, so this is your groundwater. Let me write here. So I was telling you that if water moves down, I was telling you one thing, if water moves down layer by layer, that is percolation. If water moves down layer by layer into the soil, that is percolation. That is number 4. That is number 4. Number 4 is what? Percolation. Sir, what is the difference between infiltration and percolation? See, infiltration means water is moving from topsoil only, but percolation means what? But percolation means what? It is, you can say, moving from one soil zone to lower soil zone. Percolation means what? Movement of water. Percolation means what? Movement of water. Percolation means what? Movement of water from one soil zone to lower soil zone. From one soil zone to lower soil zone. That is your percolation. This is the difference you need to understand. Okay, yes or no? Okay, so percolation means what? That water is moving from one soil zone to another soil zone. Okay, that is percolation. So this is that basic difference. Infiltration means water is getting inside the topsoil and then it is percolating deep down. That is your fourth part. Okay, after this, you need to understand, after this you need to understand some water will be transpired through the leaves of these plants or trees. Yes or no? Some water will be getting transpired, which is number 5, which is nothing but transpiration. Transpiration means water is getting discharged into the atmosphere through the leaves, through the leaves of these trees. Okay, that is your transpiration. That is your transpiration. That also you must have heard Okay, some water is getting discharged into the atmosphere. Some water is getting discharged into the atmosphere through the leaves of your plants. Okay, so transpiration is what? Transpiration is nothing but the soil moisture taken up by roots. Soil moisture taken up by roots and and discharged into atmosphere and discharged into atmosphere. Yes or no? Taken up by roots and discharged into atmosphere through leaves of plants and trees. Okay, like that. So this is your transpiration indicated by T. Transpiration will be indicated by T. Precipitation will be indicated by P. Evaporation will be indicated by E, like that. Okay, so we have discussed this. After this, the sixth one which we have is your depression storage. Some water, you all know, after rainfall, some water will be filled in these depressions. Okay, some water will be filled in these depressions. This is your sixth one. Okay, this is your sixth one. Sixth means depression. Depression means the you can say small formations or small holes which will be filled because of water. Okay, so this is your depression storage. Some volume of water is stored in this depressions, that is nothing but your depression storage. I hope this is clear to you. After this depression storage, some water, you also know, some water will be evaporating while falling on earth. See, when this water will be falling, meanwhile falling, some water will get evaporated. Okay, some water will get evaporated in the meanwhile. See, you need to understand, let us assume this water is falling, and when it is falling, some water has evaporated meanwhile. That is your seventh. Okay, that is your seventh, known as Varga. So if someone asks you like what Varga is, you will say, what is Varga? You will say what? Sir, the rain or snow, okay, whatever is falling, let us assume rain. So the part of rain that evaporates while falling through air, that is Varga. Okay, so rain that evaporates, rain that evaporates before before reaching the earth. Okay, some portion of rain evaporates before reaching the earth while falling through air. Is your Varga. Okay, while falling through air is your Varga. Yes or no? Yes or no? Simple. So you need to understand rain which evaporates while falling through air. Some portion is evaporated meanwhile only. Okay, some portion is evaporated meanwhile only, that is your Varga. Is it clear? Very simple. Now you need to understand some water, apart from this, some water will be intercepted by these trees. Okay, let me use different thing here. Okay, some water will be stored, or you can say will be intercepted by these trees. Yes or no? Or let us imagine we have a building here, and on that building some water has stored on the top. Okay, so you need to understand some portion of water, when it is falling, some portion of water will not be reaching the earth's surface. Some portion of water will not be reaching the earth's surface. You need to understand this. Some portion of water does not reach the earth's surface, and it is intercepted by trees, plants, crops, buildings, roads, etc. Okay, we have different components which can intercept this water. Okay, we will name it, we will number it number 8. Okay, number 8 I will give to this. This is nothing but your interception. Okay, this is nothing but your interception. See, interception simply means the water which is intercepted by these obstructions, and that water has not reached the earth's surface. Whatever water will not reach the earth's surface, and is being obstructed by these trees, crops, vegetation, okay, or you can say buildings, etc., is nothing but your interception. So if someone asks you like what interception exactly is, if someone asks you like what interception exactly is, you will say it is short term retention of water. See, whatever, you all know that after rainfall some water gets collected on the top of building, but you need to understand that water which is collected on the top of the building, yes or no, will evaporate after some time. Yes or no? That water will get evaporated after some time. That's why I am using the term short term here. Why short term? Because you need to understand that water will subsequently evaporate. Yes or no? So I am saying interception is nothing but short term retention of water, short term retention of rain, short term retention of rain, short term retention of rain over obstruction, short term retention of rain over obstructions such as buildings, roads, such as buildings, roads, vegetation, etc. Okay, so these many obstructions we have discussed. Many other obstructions are also there, but basically you will encounter these obstructions only. Some water is you will see that after rainfall some water will be collected on the top of the building, some water will be deposited on the roads, some water you will see on the vegetation itself, trees itself. That is interception. But you need to understand that portion of water will not reach the earth's surface. That is interception. Okay, that portion of water will not reach the earth's surface. Yes or no? Shehbaz is asking, sir, can we make notes during the class? See, I will give you sufficient time so you can make the notes during class also. But if you don't want to make it during the class and if you want to listen only, the notes, you will get this in your PWR from where you can note it down quickly also. Okay. So both options you have, it totally depends on how much time you have. If you want to note it down in the class itself, you can make it in the class itself. I'm giving you sufficient time here. Okay. Okay. So after this interception, interceptions are I have clearly understood now. Okay, whatever water will be intercepted by the obstructions is your interception. Okay, whatever water will be intercepted by your obstructions is nothing but interception. Okay, so I hope this 7th and 8th is clear to you. Now one boy is saying 7th and 8th repeat. See, 7th is, you need to understand what is 7th. 7th is what, when this rain will be falling, you need to understand when this rain will be falling, some water will evaporate while this rain is falling. Yes or no? While this rain is falling, that rain will evaporate some portion. That is 7. That is Varga. And when this rain will reach your near your earth surface, some water will be obstructed by trees that will not reach the ground surface. Yes or no? That will not reach the ground. That is interception. Interception means the water which is obstructed. That is interception. That is 8. That is 8. You can see that some water has been blocked by this tree and it is unable to reach the ground. Okay, that is interception. 8 number. Is it clear now? That water will be obstructed by buildings, roads, vegetation, etc. I hope this is clear to you. Now we'll move on to the last one, which is nothing but your runoff. After this, so sir, you are simply saying we have evaporation, we have precipitation, and after precipitation we have different kind of losses. After precipitation, sir, you are saying infiltration is there, transpiration is there, evaporation from rain is there. Okay, sir, some water is getting stored in the form of in depressions, some water is going here, some water is going there. So many losses are there. After precipitation, many losses are there. Now what will happen after losses? Can you comment? Can you comment what will happen after losses? Yes or no? Can you comment, Sushil? Can you tell me? After all the losses, you will see that water will start running off on the surface. Whatever water will be left, you will see that water will start running off either above the surface or below the surface. Okay, the water will start running off and ultimately it will uh, form small streams, and those small streams will ultimately join your main river. Yes or no? That is your runoff. Okay, see, runoff basically can happen above the surface also and below the surface. and some water runs off in the groundwater also. Okay, see, water runs off at three levels: at this level also, or at this level, or at this level. Okay, water can see, but the water which will run off at the ground water level will take too much of time. This water, this runoff is quick. Yes or no? So the water which is above land, that is overland flow, and the water which is flowing just below the surface is your interflow. What it is? It is interflow, or you can say subsurface flow. Subsurface flow, because it is below the surface. Yes or no? Yes or no? Kindly comment, everyone. Kindly comment, everyone. So we have number 9. We have number 9. Number 9 is nothing. Number 9 is nothing but runoff. All the water which is remaining after all the losses. So precipitation has happened. After precipitation, all the losses have happened, and after all the losses, whatever water is left off is running off. Okay. And sir, you are saying we have two kinds of runoff. Water runoff either above the surface, white water runs off either above the surface, which is nothing but surface runoff, which is nothing but surface runoff, or below the surface, or below the surface, which is nothing but, which is nothing but, which is nothing but subsurface runoff. Okay, surface or subsurface. So runoff is happening in two forms: above the surface or below the surface. You need to understand this. So below the surface, whatever water is running off, we are calling it as interflow or subsurface flow. We are calling it as interflow or subsurface flow. So these are all the components. These are all the components of your what? Of your hydrological cycle. So at last, what is runoff? Runoff simply means volume of water. And see, you need to understand, after runoff, all the water will ultimately reach your river. After runoff, all the water will ultimately reach your river. Yes or no? You need to understand this. Okay. So after runoff, all the volume of water will ultimately reach your river, the main river. So volume of water drained by river, volume of water drained by river, volume water which is drained by river at outlet of catchment is your runoff. Now you must be wondering, sir, what is outlet? What is catchment? Can you make me understand the meaning of this? What is outlet? What is catchment? See, you need to understand. See, let me conclude this water cycle, then I will tell you what exactly catchment area is. Okay, the very next topic is that only. So hydrological cycle simply means water cycle. And sir, in water cycle, if someone asks me like, simplify water cycle, so I will simply say water cycle is basically a three-step process. Water cycle is basically, sir, a three-step process, you are saying, in which, sir, the higher masses is your land mass. See, land basically is at higher level, sir, you are simply saying, and ocean is at lower level. Yes or no? See, you all know that water ultimately gets collected at a lower level. Yes or no? See, this is your higher level. This is a higher level. If I want to summarize this entire water cycle, this is your lower level, and we all know water ultimately deposits in your lower level. Yes or no? So let me assume this is your oceans, this is your landmass. So basically, sir, you are saying, it's a three-step process. This is your evaporation. Okay, from oceans, evaporation will be more. See, you need to understand, we have more water in oceans, so it will get evaporated. Also, some water falls back in the form of precipitation over oceans also, but precipitation is less, evaporation is more. You need to understand, oceans have more evaporation. You need to note one point here. That evaporation over oceans is more, around 9% more. Evaporation, you need to understand, evaporation over oceans is 9% more than precipitation over it. More than precipitation, which means that the amount of water which is being evaporated from your oceans is 9% more than the precipitation which is happening over the oceans. Okay, you need to understand. See, some water will fall back also. some water will fall back also. Sir, you are saying that evaporation is more than precipitation over the oceans, which simply means water is going away from oceans. Net conclusion is that more water is getting out of your oceans, around 9% more, around 9%. See, rainfall is also happening, but in less quantity. So I will say that evaporation is more over oceans, and this 9% of water is ultimately moving out from oceans and falling on the land masses. See, when this cloud will move your land masses, precipitation will occur. Now on land masses, you will see precipitation will be there. See, on land masses, you all know evaporation is also there. On land masses, you all know that evaporation is also there. But what is more? Sir, on land masses, I will say precipitation is more. On land masses, precipitation is more. Yes or no? So here, you are saying that on land masses we have more precipitation, and above oceans we have more evaporations. So overall, water is moving from here, from there to here, from oceans to lands, and whatever extra water which is stored on the land masses, we store it in the form behind dams, we store it in lakes, we store it in rivers behind dams. Okay, so we try to tap that water. I told you that India receives uh, given quantity of rainfall that we try to store so that we can utilize that water. Okay, I have told you this thing also. So overall, you can say water is coming from oceans and getting stored on the land masses, and after that, whatever water is left off, whatever water is left off is ultimately running off again. That is your third part. After your precipitation, after all the losses have happened, runoff will start to happen. Okay, runoff will start to happen. Yes or no? So I hope this entire thing is clear to you. So basically, sir, only three steps are there: evaporation, precipitation, and after all the losses we have runoff. After all the losses we have runoff. Yes or no? Is this thing fully clear to you? Okay, yes or no? Is this thing fully clear to you? Kindly comment, everyone. Is this thing fully clear to you? So some extra water is getting evaporated from the oceans, which is falling on the land. Some part of that water we are utilizing, and whatever water is left off is going in the form of runoff. Okay. Now if we have a look on the chapters, I have not told you all the chapters till now. Now you need to understand, after this water cycle, now you will be able to understand all the sequence of chapters. Okay, so what we'll study after this class, firstly you need to understand we have introduction to hydrology, in which we have discussed the water cycle, the basic things. We have understood why we have studying hydrology. I've told you all these things. Okay, and how your global water is distributed, that we have also discussed. After this we'll study precipitation. Okay, after this we'll study precipitation. After your precipitation, you need to understand, in the water cycle we have discussed just now, that after precipitation all the losses will happen, all the abstraction or losses will happen. Okay, yes or no? So the next chapter will be losses from precipitation or abstractions from precipitation. And you all know that in precipitation, losses in precipitation, if we consider losses from precipitation, we have evaporation, we have transpiration, we have infiltration, some water was collected in depressions, depression storage was there, interception was. See, these are all the losses. So we'll discuss all the losses in this chapter. After this, after losses, you have seen runoff is there. You have seen runoff is there. Yes or no? After your losses, runoff is there. Now you need to understand, runoff basically happens in form of small streams. Those small streams joins, and forms stream flow, okay, and forms stream flow. So we have to measure that stream flow, we'll discuss that also. Okay, after stream flow, all the water will ultimately reach your river, where we'll study hydrograph. Okay, I know that you are unable to understand the stream flow and hydrograph. So for that, I will make sure that you are able to understand one more term, which is nothing but your catchment area. This is a very beautiful concept. You need to understand what catchment area exactly is. See, catchment area is also known as watershed. In USA, we call it as watershed. In some countries, we call it as basin. In India, basically, we call it as catchment area. Some place we call it as water sink. Okay, like that. Different names are there. Okay, now tell me, you all have wash basins in your houses. Wash basin is a very simple, you must have seen stoneware in which you wash your hands. So it is a kind of bowl. It is a kind of bowl in which whatever water is falling is remaining in that area and is ultimately draining into the sink, which is placed at the lower level. Have you seen the sink? Have you seen water basin, wash basin? Yes or no? Have you seen it or not? In a similar fashion, we have a catchment area. In a similar fashion, we have a catchment area. See, this is your map of India, and in India, you have a very huge basin. You have a very huge basin, which is your Ganga basin. Okay, you all know that Ganga is one of the largest rivers of India and one of the holy rivers also, sacred and holy river. You all know it's one of the pious rivers. So you can see in this entire area, whatever water will fall. See, basically this is your Uttarakhand, Uttar Pradesh, and Bihar region. Basically your Gangetic plain. Why I'm calling it as Gangetic plain? Because whatever water will fall in this area, ultimately it will reach in your Ganga basin only. It will reach in your Ganga basin only. Yes, it will reach in your Ganga river only. See, Ganga river is at the center. Ganga river is at the center, and many small streams, small rivers are joining and ultimately draining off all the water into the main Ganga river. Which means this is a kind of wash basin only. Whatever water will fall in this area will ultimately reach at the lowest level. Yes or no? Have you understood this or not? Yes or no? Can you tell me? Yes or no? So I hope this is very clear to you. What see try to understand with this diagram. See, in this diagram you need to understand this is the highest line. See, this is your highest line. Okay, this is your highest line. Highest line means ridge line. Ridge line means the highest line. Ridge line also is known as, it is also known as water divide line. It is also known as water divide. Why it is known as water divide? Because whatever water will fall here, it has two options. Either it can go into this catchment or it can go in the adjacent catchment. Yes or no? So this is your highest level. So you need to understand, when water is falling in this entire area, it will start forming streams. Okay, small streams, network of streams will form. A small network of streams will form, and that water will ultimately reach your main river, which is at the lowest line. This lowest line is known as your valley line. Kindly comment what is the name of lowest line. Lowest line is valley line and the highest line is ridge line. Okay, so you need to understand one thing. You need to understand one very basic thing, that if I'm taking a cross section of this, you need to understand see, you need to understand whatever water is falling here. See, this is your highest point, this is your highest point, this is your ridge. Okay, whatever water is falling here will ultimately you can say will flow through stream, join you can say it will form a network of streams and ultimately will join your lowest river. Okay, river is at the lowest level. Okay, this is the river. So whatever water is falling ultimately is reaching your river only. You must have seen it when you have visited your any hill station. You must have seen that on both sides we have mountains, and at the lowest portion we have a river, and all the water which is falling within that catchment area, that water is ultimately joining your streams only with the via network of small streams. Yes or no? So after runoff you will see runoff happens basically through the network of streams, and those network of streams will ultimately drain into the lowest river. Yes or no? So this is a catchment area. This is a catchment area in which you will see we have a ridge line and whatever water will be falling in that ridge line will ultimately drain off into the lowest portion, which is your valley, which is your river. Yes or no? So this is your catchment area, this is your watershed. So whatever water will fall in this area will ultimately reach into the main central river, will ultimately reach into the main central river. Yes or no? So have you understood this concept? This is a main river and this is your outlet. See, when your catchment is over, when your catchment is over, at the end of your catchment we have outlet. This is nothing but outlet of catchment. So entire India is divided into different catchments. So in India we have different catchments, and in each catchment at the center we have one river. Somewhere you will see Ganga is there, somewhere you will see Yamuna is there. Okay, see, this entire Uttar Pradesh can be divided into small sub basins also, into small catchment areas also. See, this is a very big catchment area. This is Ganga catchment area. If we divide into sub areas, see, this is your Gandak catchment area, this is your Ghagra catchment area, this is your Kosi catchment area, this is your Yamuna catchment area, this is your Gomti also. We have Chambal catchment area. Like that, big catchment areas can be divided into smaller sub catchments. Yes or no? Like that. So entire India, in entire India you have different catchments of different rivers. Okay, you must have seen these rivers, witnessed it everywhere across the entire Indian subcontinent. Okay, so I hope this catchment area concept is clear to you. So ultimately, sir, what is happening, that whenever rainfall will happen in this catchment area, sir, I will see that through the network of streams all the water will run off and ultimately drain into the main river, and you will see that discharge of main river goes up. Suddenly after the rainfall you will see that the discharge or the flow in this river will go up with passage of time, and that we measure with the help of hydrograph. Yes or no? So I hope now you have understood the catchment area also. I hope now catchment area is also clear to you. So after the losses, runoff happens, and runoff happens with the help of streams. Through small streams all the water will run off and join the main river. Okay, so we have to measure that stream flow, and in that stream flow we basically measure velocity, discharge. Okay, what is the level of water that. After that, when your water will reach your main river, we'll try to make hydrograph is nothing but discharge versus time graph. It is nothing but discharge versus time graph. You need to understand one thing, that after rainfall what will happen, the graph will go up, and after your rainfall has stopped, graph will again come down. This is nothing but discharge versus time graph. So we have to understand what hydrograph is after that. Okay, after your hydrograph we will understand what is flood, because if rainfall is in excess quantity you will see that this discharge has crossed the limits. Okay, so we have to understand flood, we have to understand flood routing. We'll try to understand what flood routing is. So I hope after that we'll uh, study groundwater. So these are all the chapters of your hydrology. I hope you have understood the sequence also. So basically we have done the introduction part. After that we have done precipitation. After this we will discuss your precipitation. After that, losses from precipitation. After losses, runoff happens. Runoff happens with the help of stream flow. Small streams joins to form network, and ultimately the water goes into the stream. Okay, after which we have hydrograph, which means that we have to study the discharge versus time graph. Okay, this is a very important chapter from gate point of view. Okay, if I'm talking of gate, this chapter is one of the most important ones. Abstraction, precipitation, these chapters are very important. After which we will study flood routing, and groundwater. So these are all the, you can say, 9 chapters that we have to study in this entire subject. I hope this is clear to you. Yes or no? I hope this is fully clear to you. So we'll end our class here. Okay, see, this is your entire chapters. So hydrological cycle, precipitation, evaporation, evapotranspiration, watershed infiltration, unit hydrographs, flood estimation, routing, reservoir routing, and at last we have groundwater. So these are all the chapters which I have told you in the correct sequence so that it is fully clear to you. So in today's class basically we have discussed what is hydrology, why we are studying it. Then we have come up with global water distribution. After that we have discussed the total water which is present in India and across the globe. Then we have discussed the water cycle, all the various phases. Okay, I hope this is very clear to you. After that we have discussed the all we have written all the definitions of your phases of water cycle, and at last we have discussed what is catchment area exactly. Okay, so I hope all these concepts are fully clear to you. So this is our end. Everything is fully clear to you? Kindly comment once, then we'll end this class. So I hope in today's lecture you are fully aware of the concept of water cycle and with the concept of catchment area. Okay, yes or no? So we'll catch up tomorrow at the same time, 10 p.m. Okay, classes will be running from Monday to Friday. Okay, from Monday to Friday every day we'll study some topics, and gradually we'll finish the entire 9 chapters which I have told you today. Okay, so I hope you have liked the session. So share it with your friends so that everyone is able to get the knowledge from these beautiful lectures. Okay, so take care, stay blessed. We'll catch up tomorrow and we'll continue from catchment area only. Okay, stay blessed, take care, good night, and stay happy.